What's up, guys? I'm doing another screen recording. Why? Because I needed to get this off my mind, and um, PAULY'S had mentioned or asked another great question on this one I just did on this 2016 GMC Yukon 5.3 with the heated seat cushion. It's a good question. So let me show you something real quick. If we go into that service manual and we go to wiring diagrams, right? System wiring diagrams. What he was asking is whether or not the ground, so we got to go to the power seats again. Adjustable pedal circuit, no. Climate controlled heating circuits, okay? So here is the driver cushion seat blower assembly. The driver's seat in the driver's seat cushion. No, it's underneath it. Notice that it's ground for this. That would be for this blower motor, and that would be for this module all together. Is on G311, base of left B pillar. That's for the driver's seat cushion blower motor assembly, or the control module, if you will. Here's the seat back. Oops. I even do it on a computer. For the back seat, or the actual seat back blower motor, because it actually has a blower motor in the seat back itself. We also have its ground for its blower motor. Now this one was working just fine. So is the driver's seat. This one was working just fine in the cooling mode. It just wasn't working in the heating mode. So these two blower motor assemblies both share the same ground. They have different junctions where they come in. Junction 318. Junction 313 and 318. But you can see here, junction 318 and 313. Okay. Notice that all these grounds come together at the same junctions, and this is the heating element. Okay. This one's in the seat back. This one's in the seat cushion. This is the one with the problem. So the very fact that this one is working, this module is working, and they all are sharing the same ground, and everything else is working that has this ground. But the only thing that's not working is our seat element supply voltage, or not supply voltage, but this heating element is not working. But we have the pulse width modulated, the 12 volt pulse width modulated feed going to it, because it's power side switched, right? Because its ground is at G311. What he's saying is you don't know for sure that from 2 to ground is good. And he's right. I don't. I don't know if you're actually saying that, 8PAULY'S, but that's what I assumed. I'm taking a gamble here. I really am. Because I'm taking an ohm meter. I'm disconnected here at the blower motor assembly, and I'm putting one lead in here, and I'm ohming out this wire through the element right to ground, but I'm not at G311. I'm not actually, like, my other end of my lead for my test light is not hooked to G311. It's actually hooked at, well, let me show you where it's hooked at. I'm just going to go back to ground distribution, and I'll show you where I'm hooked at. Ground distribution. Now, I've already went through this, guys, for the sake of time, because there's 11 pages for the ground distribution on this vehicle. So it's on diagram 5. All right. 7, 6, and 5. Here's 5. A cigarette lighter receptacle. instrument panel accessory power receptacle. Go to junction 241. Remember that. 2 splice J4 242 4 of 11. Here's 4 of 11 right here. Okay. Junction 242 is right here. Okay. See it? And if you look, they get their ground from G210, inboard of right A pillar. Now, look at this one. Oh, where is it? It's on here. Center console compartment lamp, center console compartment cooler module with cooler compartment floor system console rear accessory power receptacle. Center console compartment accessory power receptacle. So if you look where these go, down to J339, sharing it with all of these other things, but that comes down to junction 241, which is to ground 210 on the A pillar, on the right A pillar. Now you got to think about that. The other one's on the left B pillar. So from the B pillar to the A pillar, I'm basically going to get, my resistance value is going to be elevated slightly. And there is a possibility that I have a bad ground. And I wouldn't know. I really wouldn't know, to be honest with you. But based on what all the other things that were working, I'm willing to take that risk. I'm willing to take it. Now, that's to answer your question, 8 Power Zero. I was taking a gamble. Could I be wrong? It's possible, but I doubt I will be, based on everything. Now, but looking at this after the fact, what I want to show you guys is how this thing works. So if I come into accessory and equipment, I go to seats, seat heating system and seat cooling system. If I look at my schematics for the driver's seat, okay, right here we have our fuse, our 15 amp fuse, and it's a shared power feed between both blower assemblies, one in the cushion, one in the actual seat back. Okay, they both get their power feed from the same fuse, so it's not a power issue. They both share the same ground. It's not a ground issue. The BCM, if you look, the BCM is also tied in on this power feed circuit, and it's also tied in here, internal. So what exactly is the BCM doing here? Because if you look, it's got a switch with a ground symbol inside the BCM. Well, it's switching and it's pulling that voltage low, but there's some kind of regulator in here that's interpreting inside this logic that signal, that pulled low signal from the BCM. The BCM is in control of both these blower motor assemblies, and it's doing it on one wire. It's a basic, low speed CAN type communication style. Okay. And then when you look at this, each blower motor assembly has the motor internal to it, so it's controlling its power and its ground based on this 12 volt feed it's getting. It's always going to get this battery positive feed. All the BCM is doing is monitoring that feed. Okay? You can see it's monitoring that battery positive feed, both on this side and on this side. And it's also monitoring the internal 12 volt regulator, I would imagine, inside the actual blower motor assembly. I don't know if that's what or capacitor, whatever it is in there. I would imagine that's what it is. Nevertheless, all it's doing to heat up, this is for the cooling portion. This is for the heating portion. So all it's doing is it is switching power. You can see the switches to the actual heating element, and the ground's already there. So it's just a pulse width deal to get them to work. Very straightforward. If we look at diagnostic information and procedures, and we come down to heated and cooled seats malfunction with Cadillac KB6, Chevrolet or GMC with KB6, and we go to circuit system testing, and we come okay, now this is basically going to have you doing ohms checks, wiring, all that. Okay, I want to show you this. The ignition must be cycled off with the heated switch in the off position for 5 seconds when the engine is on between each test in order to reset the blower motor with the heater element disconnected. The seat blower assembly senses a fault and open in the control circuit. Because of the fault, the blower assembly will only turn on the output to the heater element for approximately 1 to 2 seconds. Because of the type of material used in the heater element, a reliable resistance value is unavailable for a component test. So there you go. Good question. My gut is telling me I'm right, but I just thought people should know that. What else was I going to show you in here? Oh, okay, circuit system testing. That's all I wanted to show you in that part. So let me get rid of wiring diagrams, that part. Let's go into repair instructions, and let's think about this. Now we're kind of thinking before we even diagnose it, right? Front seat cushion, ventilation blower replacement. What do we want? Front seat cushion heater replacement with KA1. Yep. And there you go. It's telling us what we have to do. Now, if you're doing a passenger side, you got to program the inflatable restraint passenger presence system after replacement. Okay, what they're talking about here, I believe, is occupant calibration for the passenger side. I could be wrong. Go correct me if I'm wrong, but I did read into this because that was something I was concerned about moving into this. So I already read into that. My assumption is that you can do that using a suitable scan tool and just calibrate the system. I don't think you actually have to reflash a module or anything like that. Could be wrong though. But from what me reading. That's it on that. Description and operation. Now in here, they've got heated seats description and operation. Now this is only if you didn't have the cooled seats option, but this is heated cooled seats description and operation. We're not dealing with the rear, we're dealing with the front. Why they don't label this front is beyond me. So we click on this. The driver and front passenger heated cooled seat system consists of the following components. This is nice because they put it in its call out. Heated cooled, the switches, the BCM, the blower motor assemblies, the cushion for the cushion assembly and the back assembly. Those are basically our sub modules to the BCM. And then our heating elements are outputs. They're the actual loads on the circuit, but these sub modules, you have a switch input, the driver's side switch, the passenger side switch, the one I was pushing in the video. Switch input to the BCM. BCM interprets that switch input, knows what to send out using that pulse width, that pulled low 12 volt signal on that control wire I was showing you guys. It does that to each blower motor assembly. One in the driver's back, one in the driver's cushion, one in the passenger's cushion, one in the passenger back. And then those blower motor sub-modules of the BCM will pulse width modulate the 12 volts to the heating elements within those cushions. Pretty straightforward, but that's how it works. And then they give you the call-out numbers. These are the numbers assigned to each module, like their call signs, okay, and what they are. Pretty straightforward there. This is the BCM's job. The BCM monitors the heated, cooled seat switches through the LIN bus message inputs, that would be from the switches, and determines the heated, cooled seat operating modes and temp levels. Each heated, cooled seat is capable of operating in 3 modes, and we've seen that in the video with 3 different temp levels. Now the BCM controls the operating mode of the driver and passenger seats through a separate pulse width modulated signal circuit. We've looked at that. It actually pulls it low, the BCM does. Each mode and temperature level is commanded by the different duty cycle. Okay. The pulse width modulated signal circuits are referenced from battery voltage by the blower assemblies and pulsed low by the BCM, right? We can see that in the wiring diagram. Now, what was I going to say about that? Yeah, that's pretty straightforward. Their powers and grounds. This is for the blower motor. It's going to tell you where they get their power feeds from. Now, TEDs. You're going to see that acronym. Here's the blower assembly. Each heated, cooled seat has 2 blower assemblies, one located on the seat cushion and one located on the seat back. Each blower assembly contains a thermoelectric device and a blower motor. The thermoelectric device is mounted, or the TED, is mounted downstream of the blower motor. Each TED consists of a circuit of positive and negative connections sandwiched between 2 ceramic plates. Each ceramic plate is equipped with copper fins for a cool exchange. The air flowing past these fins is directed as conditioned air into the seat cushion and seat back, or directed into the cabin as waste air. Interesting. Pretty cool. That's for the cooling operation. Obviously I didn't sit here and read all this, guys. I'm doing it now. But if we wanted to look at the heated seat operation, when the seat blower motor assembly receives a heated seat command, it applies a high side drive pulse with modulated signal driven at the required duty cycles to generate the appropriate effective voltage to the heating elements to attain the commanded seat temperature. So those heating elements have a resistance value that they've already calculated. So that pulse width modulated 12 volt feed, or duty cycled feed, if you will, to those heating seat elements is already, like, the time on. It knows, the BCM knows that that's going to get it to a certain temp. That's a medium temp. The heated seat element system utilizes a self-regulating heating element, which is different from the non-regulated heating elements with a seat temp sensor previously used on GM vehicles. So there's no heated seat temp sensors anymore. In the self-regulating type of system, the temp feedback to the control module is not required for temp regulation. That's because they already know, they'll pulse width modulate it. And if it's not working, it's just not going to work like it is now. The heating element material itself regulates the surface temperature based on the effective voltage applied to the heating element. So basically it just maintains one setting regardless. Rear heated seats description and operation. Okay, we're not going to go into that. So that's it in a nutshell, guys. Not too complicated, nothing too spectacular. Should answer your questions. How it works. It's not a tough system to diagnose. I mean, if we go back into our schematics for the driver's seat, okay, really there's not much to test here. Okay, we tested right from pin 2 there on the seat blower assembly driver back. I'm sorry, not pin 2 there, but pin 2 here. It doesn't matter. They're same concept. We're testing from here to here, basically to ground, but our ground is at the A pillar. So we're going through the body of the car. And it's going to affect the amount of resistance through these heating elements. But if we know passenger side is working, and we do that measurement and we compare it to our driver's side and they're different, it pretty much narrows it down. Considering we know that, this isn't passenger side, I'm just using it as an example, but since we know that there's so many other things sharing this 311 ground, that we've got to assume the ground is good. It's not even worth our time to tear up body paneling. By the time we replace the cushion element, if we had a bad ground, even if we did have a bad ground, we made a bad call, it would be quicker for us just to run a new ground, to be completely honest with you. Nevertheless, that was the reasoning behind it. So if you have any questions, guys, drop them down. I hope you liked it. This is my part 2. Hope I answered your questions. It's not that complicated of a circuit, really. Pretty straightforward diagnosis. But what I really am concerned about is showing you guys where to go and find your information. That's, if you're using ProDemand, I don't know why, a lot of guys seem to hate ProDemand, but you just got to know how to find a lot of the stuff. I mean, I have Identifix too, guys, but it depends on what I'm working on. Now, for a GM, there should be no reason you can't find what you need in ProDemand. Everything's in there. You just got to know how to navigate it. And a lot of times, before guys start diagnosing even something simple as this, they don't go in and just do some quick reading on how the system works. I mean, I did this in a matter of, I would say, 10 minutes. About 10 minutes at the most it took me to go through what I wanted to go through and actually understand, get a basic understanding. I mean, we're not talking, chapter books here, guys. We're talking basic diagram, real quick, down and dirty, read it, a couple paragraphs, and now we're armed with what we need to know when we go into the actual wiring diagram that's redrawn by Mitchell. And we got to be careful here too, because we can run into issues with this. But now at least I have an understanding of what is happening here, okay, and what's expected, and what the most obvious route would be, okay. The most obvious thing is obviously the element is bad. So thanks for watching, guys. Hope you liked it. Till the next one.